pH, if you'll recall the pH situation from a previous course, it comes from the auto-ionization of water, because it turns out that pure water has all these hydrogen bonds going on. And every once in a while, one of these hydrogens will go ahead and jump over to one of the waters, and you'll be left with the hydronium ion and the hydroxide ion. Now, this doesn't happen a whole lot, but it does happen enough that it forms the basis of our pH system. And it is in an equilibrium. So we have, as you can imagine, these always end up trying to be equal, because if it's happening just between these two, there's only one thing that can happen. If one of them goes up, the other one is going to go up. Anytime you make one of these, you're making one of these. So this auto-ionization is why we get these very small but very predictable concentrations of hydronium and hydroxide ions in pure water. That gives us yet another K. So this equilibrium constant, K for water, there's the W. If you think about it, there's no denominator, because both of these were the pure liquids that we ignore when we form an equilibrium constant. So it depends only on the concentrations of these. And it turns out for water, they're always going to multiply together to form 1 times 10 to the negative 14th. That sets us up for when things are not pure. You will have an inverse relationship between the hydronium and the hydroxide ions, because you're always going to go to this number. And if you're trying to find hydronium, that would be this number divided by the concentration of the hydroxide, and vice versa. Yeah, what the heck? You just told me they were equal. In pure water, they're equal. But if you put something else in it, you're going to shift it. The one thing that will be true is when you multiply these together, you're always going to get this number. Pure. This chart shows you, pure water is neutral. Now, if you start looking at other things, you find out that human blood is slightly basic, and milk is slightly acidic. Rainwater is more acidic than that. Tomatoes, oranges, vinegar, lemons, your stomach acid, that's why it burns when you throw up, people. And 1 molar hydrochloric acid is set at 0 because it's all dissolving. Okay, and we're talking about concentrations, we're talking about molarities. We're going to form, if this all dissolves, then we're going to get 1 molar hydronium ions. And that would be, definitionally ends up giving us a 0 when we do this. Okay, that's kind of looking ahead. So we have, all right, what's more acidic than, more basic than blood? Well, seawater is, because there's different things dissolved in it that tend to bring the basic level up. Baking soda is. That makes sense, okay? That's one thing that people used to use and still do if they have a little bit of heartburn. They will take a little baking soda and water and drink it to try to settle it down. They'll use that to neutralize their stomach acid. Milk of magnesia, guess what that's used for? Yeah, upset stomach, get that stomach acid under control. Ammonia, drain cleaner. And whoa, sodium hydroxide is the high end. Yes, it's one of our strong bases, just like we had the strong acid down here. 1 molar sodium hydroxide. Gonna all form 1 molar hydroxide ions because it all dissolves, goes to completion. So pH and the auto-ionization of water. If you have an acidic solution, you're going to have more hydronium ions than hydroxide ions. If you have a basic solution, the opposite is true. If you have a neutral solution, they are exactly equal. And you can see, since they are exactly equal, if you multiplied the two of them together, you would get that 1 times 10 to the negative 14 that we were talking about before. The yeah, I know that you've seen this before, but pH is defined to be the negative logarithm base 10 of the hydronium ion concentration. That is why when this concentration goes up, say it's 10 to the negative third, you take a logarithm, you're like, oh, I'm just stripping off that -3. Oh, but there's a negative. The negatives cancel and you end up with a pH of 3. Acids will have a pH lower than 7, bases higher. The interesting thing is, because this is a logarithm base 10, when you have a pH unit change by 1, that's 10 times the change in hydronium ion.
Exponential.
Yes. And you're taking the exponents, because logarithms are exponents. So you're looking at how much the exponent is changing.